Okay, back again. Camera's cooled off. We were talking about this thing called a live center, and this pointy part spins inside this large cylinder, this disc-like thing here. And it's so well machined and so forth that you really can't tell if it's moving. That's why I'm doing it like so. It's an amazing piece of engineering. You'd think that you couldn't put pressure at the end of something and have it not melt down on you or what have you, but it works as advertised. And the use of them is nothing at all. You just pop it into whatever the receiving tapered, and it's almost always a tailstock. You use one of these and just give it a pop and it stays stuck until you push it out mechanically. So how you use it in our case, there's one little bit of specific potential gotchas, and that is where the hole, the two surfaces, the tubular hole, the cylindrical hole, and the face of the tenon come together. That in geometric terms is infinitely small. So when you push this against that, you have zero contact area. Now it isn't obviously literally zero, but close enough that to be safe, I take one of these guys that's the same angle as the pointy thing and the end of the live center, and give it a quick one of these, just enough to create, oh, 1/2 millimeter. It doesn't take much at all, so that the contact area increases significantly when you do that. And then there's no chance of the stem spinning in this knot, which would create a lot of friction. It'd begin to melt and so forth. So other than that, it's as simple as it can be. Now earlier I talked about this guy, and as long as you can mount this guy in your chuck so that it's dead center, you're good to go. Now if you have a 3-jaw chuck, they're just keyed to, you know, like a aperture on a camera. They just kind of do this number here. If you have a 4-jaw chuck, getting something centered can be a bit of a trial. So I'll show you a device. I'm not sure if you know they even exist in this form. It's a dial indicator on an articulated arm that is completely controlled with a single knob. And by that I mean, if you turn the knob, the entire thing loosens up like a gooseneck lamp that's even floppier than that. And you give it a turn and all of the different segments in the arm freeze in place. And this thing is so handy. It's unbelievably handy to, there's literally nothing to finding your center, or I'm sorry, getting the plunger centered on the object that you want to measure. It's, I don't know who invented this or even what the internals are like. I don't care. They deserve a medal. And to add to the crazy brilliance of this, check this out. This little knob here, this is a steel plate that's not actually part of this when you buy it. Now you're going to say, well, that's just an electromagnet that, or I'm sorry, a regular magnet that's being engaged and disengaged. Well, if that were true, you'd think that this would have a lot of resistance, right? But there's like an ounce of pressure necessary for that to engage magnetically. So it's not some lever that's raising and lowering a massive magnet in there. So I don't know how this works. It's a mystery, but the very best kind of mystery, in that every shop needs one. Wasn't terribly expensive. Oh yeah, the brand on this is Noga, Naga or Noga. And they're widely available because, for obvious reasons, they're very popular. To see it or use it is to love them. Okay, on to the cutters that I used. And remember, I went with the pointed one first and then followed it with whatever this shape that I couldn't decide what it was called is the follow-up. And the reason for that is as follows. Pretend that this over here is the base of a stem, and this is the live center. This is the spinny part. And what'll happen if you're not careful, and you don't want to go jacking this up. This is a fine piece of machinery. If the stem that, or rather the tenon that you wish to create is, let's say, that size. It's smaller. You want to take off this material here, and you take this guy and run it up to where you can engage, and bingo, it could make contact with the cone here. You need to go far enough forward. You're going to be cutting in this direction like so, but as you're making your cuts and you're advancing this in that direction, then making a cut, coming back. Well, if you're not careful, one edge of that could touch this guy here, and it's going to be spinning. This guy's rotating at a high rate of speed, and so you've just jacked this up in an instant. So the obvious solution is to just take a pointed one and go in there first with it like so, and you can go as deep as you need to go without touching anything as long as you're careful. And then you put a taper on the end of that, but that's not a problem. You just flatten it after the fact. And then you've got room enough to fit this cutter in there without risk of making contact. So about the only drawback to making molded stems on a lathe is, as opposed to making them on a drill press, is you cannot test fit as you go along. You can't take the stumble and check the fit and then cut a little more and check the fit, because it's mounted. Well, obviously you've got the pins in the ends of it. You can't do that. So you need calipers. And I don't know, they run the full gamut from basic and functional to electronic readout. I like the old, obviously, the mechanical dial face ones, but these are not terribly expensive anymore. The only alternative that comes to mind is this kind of a thing. Now, you can get them in a smaller size, and what you would then do is set this to be exactly the size you want, and then open it up just a hair so that when you swept it over this is, pretend my finger's the stem on the lathe, and as soon as you got a bit of clearance, you know that you're within 5 thousandths, let's say, because this is 5 thousandths bigger than you want. And then you could take the stem off and use some little strips of paper to fine-tune the fit. That's about the only alternative I can think of to using dial indicator, or I'm sorry, calipers rather. Let's see, anything else involved in this? I don't think so. You can get lathes for surprisingly little money. especially the manual lathes from an earlier era. The one I use was made in the mid or late 1960s by Atlas. It was marketed by Craftsman, the Sears at the time. And there are two versions of that. One had bronze main bearings, and the other one had the lubricatable, if that's a word, where you would drip a type of oil in these little caps, and that's considered the better machine. And that's what I've got. It's as small as I would go. If you get a lathe, you can't turn any wood blocks or anything on there, but it works okay for stems. And I guess that's all I can think of. Be sure, this guide, I would recommend you don't try to make it yourself. You can, but it's a pain in the butt. And the guy who runs the operation there in Columbus, Ohio, is one of us. He's not somebody who's attempting to exploit a hobby and, like, here's an opportunity. No, he likes to solve problems and then come up with permanent solutions. He'll hire people to make tools and stuff for him. So rawcrafted.com, good man, good operation. Get you one of these if you got a lathe. You'll be glad you did. And I think that's it for this pass. It's been a change of pace for me. That normally it's a project, as you know, or a generalized method regarding something. And this is more a case of I've received so many questions about how do I make this work on a drill press. And they've got a flimsy Lowe's company type of drill press and one of those inexpensive spinning cutters, and they're not getting a good result. And there's not much I can do to help anybody because the problem is the equipment, not the use of the equipment. So doing it as all the last these videos have described as my recommended alternative to getting a 7-foot tall 1,000-pound drill press with a custom XY table on it. So there we go. Hope it helped you out if you were looking to solve this kind of a problem. Hope it started you on the way to finding some answers. So that's it for now. Take care. See you around.